Welcome to the Private AI Lab, the podcast where we experiment, explore, and debate the future of AI behind the firewall. I'm your host, Johan, and every month I have a guest in the lab to break down real-world use cases, challenges, and innovations shaping private AI. In this episode, Frank Denneman is our guest to talk us through the past, the present, and the future of VMware's private AI services portfolio. And we're going to dive really deep into everything resource management when it comes to VMware and AI workloads. So enjoy the episode. So let's dive right into it. Frank, you've been at the forefront of virtualization and now AI for many years. But before we dive into the kind of the serious stuff, I always like to start this conversation with, first of all, your introduction. But the second thing that I really like to know from you is, like, what was the very first time you kind of saw something around AI that triggered you in a way that you thought, well, this is going to be my career from now on?
Okay, interesting question. Okay, so my name is Frank Denneman. I work for VMware by Broadcom. At VMware, I have the title of Distinguished Engineer. I report directly into the head of AI of VMware, Chris Wolf. And so I help the teams to think about the strategy, think about the products, the roadmap, help to understand what things are coming our way. And so I don't have a really rigid, defined role. It's basically where I think people can use my help. I help because I don't have any engineers reporting into me, but what I do is I help other distinguished engineers and teams to say, hey, looking at our current platform, looking at the workload that's coming in, how can we match the hardware, the workload placement, the lifecycle management of things with an AI context? And that's interesting because a lot of people are getting started with AI and trying to figure out what AI is drinking from not only one fire hose but from like 10, right? And it's such a dynamic space where a lot of new things are happening, and the sometimes irritating, sometimes awesome, but people start to talk about new technology, whether it's already implemented like five years, right? It sounds like everybody's doing that, but when you basically dig into things, you figure out like, this is quite new. Is this enterprise ready? Because that's another thing, right? A lot of these AI factories and all of these functionalities that are currently being developed in our community, they are typically research driven. AI is coming from a machine learning background where the researcher basically said, what do we need to do? And so all the functionality that the ML engineer and the ML researcher needed was basically created on the spot. And that DNA is still present in AI. And that doesn't always align with the enterprise mindset. Things have to be proven technology, have to be consistent, they have to be reliable. Those things are sometimes at the ends of a spectrum. Yeah.
And I think that's one thing you really, I think you hit right, is that everything AI is nowadays being put on the same category. Like, we're talking about AI. Well,
yeah.
Well, we're not, because like you mentioned, there is, different kind of workflows within the realm of AI, like training models.
Yeah.
or like having a kind of a RAG application that is kind of in between like training jobs, but still you're curating things, you're adding specific data to an AI app, and at the other end of the spectrum, we have kind of the inference side of things. And then you can also kind of consume that from cloud. So it kind of feels, to me personally, like the conversations we had for years when talking about a virtual data center. Like a virtual data center, it was not just the data center. You talked about storage, about networking, about the different types of workloads you could run. You talked about automation, DevOps, and I kind of feel that the same complexity that we have known for years, that we have tried to master for years, and you've been one of the persons who wrote different books on the topic. I kind of feel we're in the same, kind of in the same process again, in the same learning curve. And maybe even more enthusiasm because we already know what the infrastructure is. We know how infrastructure works, but now for a complete other ball game.
Yeah, and I 100% agree with you. So you also asked me about what was your moment for AI, and it was exactly that. So back in the day when Kit Colbert was the CTO of the company, I reported to him, and we were always talking about resource management because resource management is my background when it comes to virtualization, right? I've been focusing on DRS, been focusing on compute. I've basically worked for a storage company for 3 years, came back, did the resource management stuff again. Now, the moment I started to talk to new work streams like with AI, with Git, it made me realize that it's exactly the same as when we just started virtualization. Before I did virtualization, and this is 2005, I was an Exchange administrator. I was an Exchange architect, and I was focused on delivering a service to a large global company. Then somebody showed me virtualization. They showed me vMotion, blew my mind, and I was like, this is awesome. But when I started to look into virtualization, I immediately had to figure out multiple things. It's a server, it's a hypervisor, which is not Windows. It's a Unix-based type of operating system. There is network involved. There is storage involved, and now I have all these different applications that need to have or that provide some requirements to that platform. Right? And they are all different. Now, the cool thing about AI is that it is almost the same, but we know the workload. That's the difference. We know that, hey, there's input, there's data input, we're computing, and then we're generating an output, right? And that's been the story for the last 60 years in IT. We've got incoming data, we've got a request, we compute things, and we get some output. But the cool thing is, we now know the data, we now know the application running and consuming the entire stack because we're still looking at storage because we need to store the data. We need to provide the data through a pipeline, through a compute entity. And we need to be able to run particular applications on it. And then we need to provide some output. If we do this correctly, we need to make sure that this thing always works. So there's networking involved, there's load balancing involved, there are priorities involved, and all of these things. So we're just basically moving up the stack a little bit more, but it's still the same. We are trying to figure out a lot of the different resources and different levels of the platform that have to work together. And I believe, to me, that was an eye-opener, and I'm like, this is awesome. But the funny thing was, every part or piece of documentation that I read was always geared towards the data scientist. It was always geared towards the researcher. Like, oh yeah, you need to have a GPU. Okay, what does that mean, right? Like, where do you have your data? Is it local? Is it remote? What's the latency requirements? Like, what's the bandwidth? Yeah, we're talking about memory inside the GPU. That's not enough, right? And so at that point, I saw there's this insane wide gap between what's being talked about in AI and how to deliver AI. And that's where basically I started to dig into that. And that's, I think, about 6 years ago already now. And yeah, we have a functionality in the VCF platform, and we're building it on a day-to-day basis, and we're trying to increase the functionality of this platform with every new release.
Now, first of all, thanks for sharing the story. Second, I think it's a great segue into experiment number 2, the deep dive, because you mentioned the platform a couple of times. What really stands out to me is there's a couple of things. First of all, I think looking at the VCF platform, VMware Cloud Foundation, which we like a couple of years ago, we knew that as like the vSphere platform with vSAN, with NSX, with everything that was kind of tied to the virtual data center, and we had a couple of tools on top of that, like VMware vSphere Operations and vRealize Automation back then. Now, all of these tools combined kind of could already offer something with a GPU and something with AI. So after that, we got Private AI Foundation, and now we're talking about Private AI Services. Before we kind of dive into what Private AI Services is and added value and stuff like that, could you kind of briefly guide us through the journey VMware went through of having the kind of the data center operating system that's capable of running those AI workloads to now having AI as a kind of a native part of the VCF stack and everything that happened in the middle?
Yeah. So we have been able to provide GPU functionality for a long, long time. It's started way before Private AI Foundation with NVIDIA, right? However, if you look at the way a GPU is consumed, that needs to be a lot of extra steps involved in order to get it exposed to an application. There's a tremendous amount of functionality that needs to be in place in order to get something going. That's from the application space. So basically looking down, I need to have a GPU inside a running entity. That can be a virtual machine, that can be a pod, a Kubernetes pod, whatever, right? Now, looking from bottom up, I've got all of these extremely expensive resources that took me a long time to get my hands on. I want to make sure that these things are used as efficiently as possible and as, well, basically high performant as possible. So we all also needed to look at the platform, and we needed to basically think about how can we make a GPU. We can talk about accelerators and all that stuff, but let's focus on GPU because that's the majority of hardware that's being used today for AI. How can we make sure that this GPU becomes a first-class citizen? And what does that mean, right? So if you look at CPU and memory, everything works with CPU and memory. Like if we deploy a virtual machine, it works with CPU and memory. If we do HA on the platform, it works with CPU and memory. It's based on CPU and memory reservations, right? If we look at DRS, the whole algorithm is focused on how much CPU do I have, how much memory do I have, what's the workload requirements, how can I make the workloads happy? So that's the alignment. If I look at all the monitoring, it's always based on CPU and memory in all the different metrics involved with those type of resources, but none with GPU. There is no HA for GPU. There is no DRS for GPU. Yeah, we can do some initial placement, but there is no, hey, this GPU is heavily utilized. Let's move this workload somewhere else, right? So that's the main goal for us from a platform perspective. Make the GPU a first-class citizen. Now, it's easier said than done because what we're talking about is that we're talking about fungible devices and non-fungible devices, basically meaning I can replace one for another, right? That you can do that with CPU and memory. It doesn't matter where you run it. I'm not talking about AMD and Intel. I'm just talking about, in general, a core. If I have a host with a 2.6 gigahertz processor and I have a host with a 2.3 gigahertz processor, I can move, right? I can move these things, I can restart it, and I don't need to reprogram anything, not from the application, not from a VM configuration perspective. I do have a problem when I get from an H100 NVIDIA GPU to an H200, even though they have 80 gigs. I'm just basically, they don't exist, but for the sake of argument, right? I need to get into the VM. I need to change the configuration in order to either place it somewhere else or restart it somewhere else. So how can we solve that? Now, these things are all things that we still haven't got an answer for, but we're getting there. So this is long term, but it gives you an idea what we are thinking about from a platform perspective, right? Monitoring perspective, same thing, right? I need to get into the GPU because it has its own management of the cores and the memory. So we need to figure out how do we do that without breaching the VM level contract. In our DNA, we always said as VMware, we're never hitting anything inside the VM. We basically deploy the VM and everything that happens inside, that's something that should not basically is nothing for us, right? That's something there. It's private, pretty much. So how do we get those data in, especially, for example, in a pass-through scenario? This is the most interesting one, which I'm trying to solve right now. If I deploy a VM with a pass-through device, I don't have a driver inside my hypervisor. The driver is inside the virtual machine. But that means I cannot basically get any metrics out of that device. And so who's managing the device now? Are we as a hypervisor a team, like the VM admins, managing this device? Because if that VM stops, we need to make sure that another VM can run or whatever, right? But I'm not getting any metrics anymore, right? So do I need to breach the VM contract and basically get those metrics out of the VM? Those type of things are we talking about, right? So that's the initial goal. And so we started to think about this and we said, instead of everybody trying to figure it out for themselves in our company, let's build a foundation. Let's build a VMware Private AI foundation, and let's do this with our main partner, the market leader of the AI hardware, which is NVIDIA. So we basically had this team together with the NVIDIA people and engineers from VMware. And what we did, this is an awesome time. We're still doing it, by the way, but we had all types of people internally, meaning that we got people from the business side, people from the customer side, people that basically are field personnel, PSO personnel, and engineers. So it was, I don't like the word tiger team, but it was a team of different disciplines that came together and that figured out, okay, what's really necessary? How can we drive this forward? Instead of a lonely engineer in his attic trying to figure out, oh, what problems do I need to solve? No, we were customer driven. We were basically getting that feedback from our field personnel and talking to a lot of customers saying, okay, if we are doing this, what do we actually need to provide this functionality? Of course, we have to deal with the number of engineers, and we have to deal with our development cycle. We cannot just say, oh, we got something, let's push another update, because that doesn't work with an enterprise level platform, right? So we had to come up with these timings as well. That was a really interesting part to begin with, right? So that started Private AI Foundation. So we looked at how can we deliver the GPU inside a construct, a workload construct that allows them to start really fast, but not being too opinionated. Meaning that if I have what we call a deep learning VM, it's like a template, we already install the driver. And we install the driver that's aligned with the driver inside the hypervisor, the vGPU driver. So we know that this is a stack, and you know this with AI, that stack inside a virtual machine or inside a Kubernetes environment is very brittle. Like you have the driver version, you have the CUDA version, you have all these Python libraries. They all need to operate in a certain window, right? But for us, it's not a bare metal system. We know there's a hypervisor driver. So that's our first step. And then we basically said, okay, that's the driver inside the virtual machine, and which library, which functionality can we expose that helps customers without limiting them. Because if you are very opinionated, you only cater to a certain people. There are always people that want something else, right? Do they need to go inside the template, deinstall everything, and then install their own stuff, right? So you cannot get a really end-to-end workflow. Like it's not a turnkey solution like basically you deploy it and it works automatically because like we said in the beginning, AI world is moving so fast that we are then constantly trying to update these templates. And that makes like then you will have template sprawl, right? So there's always this balance of helping people, but not being too opinionated, right? And we did this for the DLVM. We are doing this for an AI a Kubernetes cluster. So the moment you basically spin up a cluster, we basically say, hey, here you have your GPU operator, you have your environment that allows you to consume that GPU and with some additional AI tools, right? Now, that was our first focused foundation, right? Meaning that we introduced some functionality in the platform, we introduced some functionality that's breaching a little bit the VM contract. But then we started to think about, okay, is that the most efficient way of doing things? Because in the end, what do you want to do when you have a GPU? Typically in the Gen.AI world, you want to run a model, right? That's the thing that you want. So we came up with private AI services. Tasha Drew and team, awesome team. They actually performed some magic, and they said, how can we use the most common inference engine, VLLM, which is not developed by us. It has the same way, same naming convention, but it's an open source thing. We do contribute to it, by the way. But we said, let's start with the premise of, hey, I want to run a VLM inference engine. How can I allow somebody to basically state the most simple demands, meaning I want to run this model and I need to have this type of hardware. So model, you can basically use a model repository. Okay, what do we have? We have what's called Harbor, which is an image repository. So Elliot Davis and Clemens, they came up with this idea of let's make this model files into, let's convert them into a container image. And because it's a container image, we can easily map it into a VKS Kubernetes worker node. And so we have a element that is easily transportable, easily movable into a different thing, and we can tag things to that image, right? So let's create Harbor and let's make it into a model repository. So that's one step. So basically we have the model running or basically being stored closely to the next step, which is model runtime, meaning I want to ingest that model in a Kubernetes environment with a VLLM environment. So I'm going to use my AI Kubernetes cluster as a basis. And now we're going to install the components that need to be there for the VLLM for the inference engine to run. And then we basically say, hey, can you basically get this model from the model gallery and load it into your vGPU memory? So the last step, what we do for the customer is saying, hey, just provide me with the VM class, the template that says this is the amount of CPU, this is the amount of memory, these are the GPUs involved. And so by just creating a very small YAML file, they can trust on the platform to load the model into a GPU on the right ESXi host, on the right GPU, because if you have multiple GPUs, we also think about what is the best way to avoid fragmentation, because that's another problem, right? And then we basically get that model from the model repository and we load it into the GPU memory. And the only thing that the customer gets back is, here's your model API endpoint. I think that's the brilliant way, right? So we trust the entire VCF platform to make the decisions where to place it, where to run it, get it up and running, load all the data, and just expose the only thing that matters to the user. Now that was step one, and then we basically go into the RAG environment. I've been monologuing for a long time, so I'll let you ask a question.
Yeah, so a couple of things happening to me. So first of all, and I went to both Explore as well as Explore on tour this year. So Broadcom slash VMware's kind of flagship events to talk about the VMware portfolio. And one thing that really stands out is the kind of the private cloud strategy that Hock Tan, the CEO of Broadcom, announced a couple of years ago, let's say 2 years ago. And the commitment Broadcom has showed to build what he called, I think, like the AWS of the local data center. He wanted to build the private cloud environment that's capable of spinning up native services. And I'm guessing, and this is not a question, but this is kind of an assumption that this is one of those examples where you move away from the traditional abstraction layer, like we're building workloads based on virtual machines, to next step, we're building workloads based on microservices. And now kind of the third iteration to that is we don't talk about the workload or the methodology that we're going to spin up the workload. We just talk about the service that we can natively spin up in VCF.
Yeah. Yeah.
Okay, so second, and now I do have a question, is one of the things I hear from from the audience, but also from customers is why should I as a customer invest in a platform that offers me a hypervisor? So I would normally, like if I would spin up a bare metal Kubernetes environment, it saves me in another layer. So why should I invest in a hypervisor that runs the containers on top of that? And I know you are strongly opinionated about this, so
Yeah,
please enlighten us.
Yeah, and this has nothing to do with me being tunnel visioned. This is
No.
me talking from experience. Like as I said before, I was an administrator for a long, long time, an architect for a long, long time. What I know is that the hypervisor is a very efficient scheduling machine. It's extremely efficient. People always think the moment I add another layer, it becomes inefficient because it's another layer. True in a certain sense of the word, meaning if you have a guest OS, because bare metal is not bare metal, there has to be running in Kubernetes. It's not only the orchestration layer of Kubernetes that you need to deal with, it's also the actual guest OS running the Kubernetes layer, right? Those are two different things, but people sometimes forget that there are two different things, right? That guest OS is typically not as efficient as what we have. And that's the reason, that's one of the things. Now, another thing, and we talk to a lot of customers, right? And we are not crazy. We understand that the majority of the AI community runs on bare metal. Most of the time it's because it was an ML world first. Researchers, they started slowly. When you start slowly, you don't think about data center level orchestration and management, right? So you start off with an island and you start to figure out what's the most efficient way. That's the most efficient way. But if you have a lot of workload that needs to land on particular hardware, then a hypervisor really makes sense. One of the key differences is with bare metal is that we offer a VM construct. It's an isolated mechanism that is standardized on exposing hardware in a standardized method, in a standardized way. Well, we can expose certain things like a GPU that is different from any other GPU, but the premise stays the same. So if I deploy a 3-node Kubernetes cluster, I always know what the hardware looks like. And so I can certify and I can basically provide the same functionality, the same libraries, and I know it works every single time. Now, on top of that, if you look at the host size, there is a difference that you may not want to consume the entire environment for that particular workload. And so what we can do is we can right size that Kubernetes cluster, those Kubernetes worker nodes, in such a way that it's the most optimal data access from a hardware perspective. You cannot do that with bare metal, right? You have to provide the entire box for you. And then there's the third element. What we see with a lot of the popular Kubernetes deployments is that they say it's bare metal, make your cluster as large as possible. We've talked to many different customers, and I've talked to many different AI operators, and constantly they complain about, and this is not, hopefully this is not coming across as FUD, but if I have a large cluster and I'm doing lifecycle management on my control plane, I have outages of my entire cluster. That's not an enterprise way of doing things. We provide precision built, but still standardized environments for particular workloads. And now what we can do and what we are looking into is figuring out a way, yes, we have certain elements, yes, we have certain hardware. How can we make sure that we can provide things as model as a service, right? And we can dig into that later. So bare metal is bare metal to a certain point, because you always have to deal with your OS installed on the hardware. Is that as good as a hypervisor? Typically, no.
Yeah, I think it's definitely a great point that you made. Like, you have a certain performance to a certain extent, but you also have like the return of investment of such a piece of hardware, and I'm guessing that the like you mentioned, that the hypervisor adds a probably kind of a perfect mix to reaching the best ROI, but also maintaining the best performance for the hardware that you invested in as well.
Yeah.
Now, at the beginning of the conversation, or the beginning kind of the history lesson around VMware and the AI story, you also mentioned different ways of assigning hardware. You mentioned Kubernetes a couple of times. Now, a couple of weeks ago, you guys released a press release stating that you once again have teamed with NVIDIA to release the support of Run AI into the VMware stack. So
Correct.
What can you kind of explain about, first of all, like what does Run AI or what does it add to the VMware stack, but also how does the integration work?
Yeah. Well, the integration is as follows. We allow you to install Run AI. Well, we allow you, that's the wrong way of saying things. We support you. It's not like we're dictating some things. We support that you run AI on a Kubernetes, on a VKS Kubernetes environment, and that allows you to use the Run AI functionality for dynamic scheduling, for workload scheduling in general. Instead of just deploying a pod and consuming the GPU, you can also schedule things and allow it to consume a GPU whenever a GPU is available. All these functionalities that makes Run AI great is something that we support. We provide the VKS cluster, we provide the hardware mapping, and then Run AI provides you with that additional functionality that allows data scientists or AI developers to consume the GPUs in a way that they seem fit, in a very efficient way. With everything, it's partner driven, meaning that Run AI, NVIDIA is in control of supporting those functionalities from a software perspective. If there's anything that's wrong with the VCF platform or with the VKS environment, they will connect with us and we will work with them to figure things out, vice versa as well. If we figure out, if the customer calls us and they say, hey, we're running a Run AI environment, apparently this doesn't work in VKS, we will basically look into it. And if we deem that this is a Run AI problem, we'll basically connect with NVIDIA, and then we will help the customer to make them successful again. But overall, the functionality of Run AI aligns really well with the way we think about consuming hardware, with providing access to hardware. And yeah, it's a better together story, for sure.
One of the things that's also completely different, I guess, from quote air quote bare metal Kubernetes is that the VMware platform offers you kind of the Swiss Army knife of GPU virtualization or GPU acceleration, if you will, because we have direct pass-through, we have vGPU, we have multi-instance GPU, so MIG, and now also run AI. So, like, when do you have some recommendations on what kind of virtualization or what kind of acceleration to choose in what scenario?
Yeah, I think it's based on where you are in your path of discovery. Typically, when customers start, what we see, and this is something we advise as well, start small. Figure out a use case that you can deliver, that you successfully can deliver a functionality or a service for, right? So what we typically see is customers starting with a entry-level data center GPU, like an L40S or something close. And then, of course, then you need to figure out, okay, how do I expose that GPU in a way? Now, one of the things that we typically hear with customers that are buying a 7 to 10,000 GPU, oh, now I need to buy an NVIDIA license as well. Yeah, that's basically part of that conversation. We can say, okay, we can also provide you with a pass-through functionality. So instead of a vGPU, we can do pass-through. You don't need to buy that NVIDIA AI license. You can expose that GPU to a VM or to a Kubernetes cluster, and you can internally assign particular functionality to that pod running or consuming that GPU. That typically works, right? Now, let's move a little bit further. They already run a model, they figured out, and now they think, maybe I need to run a bigger model or multiple models, right? Maybe multiple models, but they don't need to consume the entire thing. Now you need vGPU because you cannot virtualize a pass-through device. Well, in some cases you can with Run AI, right? So now we have, instead of saying pass-through or a GPU or vGPU, you can say, I want to have vGPU at the hypervisor layer, or I want to have vGPU functionality or some sort of vGPU functionality with Run AI, right? And now Run AI allows you to say, hey, this workloads need to run right now, more like a batch type of thing. I'm going to provide you these functionality, but if somebody else needs it, I will basically deschedule you, will basically snapshot you and let the other workload run, and then basically we can go back and forth between GPUs. So it's not like time slicing or MIG, it's just a different way of scheduling a GPU device, right? Now, that's another thing. You could still run pass-through, but you have larger rocks to carry. You have larger building blocks, right? It's a full GPU. If you're comfortable with that, use it like that. Now, the next step is I need to have multiple GPUs for a workload. Let's say I have a 70 billion model. Typically, you cannot run these on the majority of data center workloads. We're getting there, right? With the latest release of GPU hardware with 140 gigs, if you're doing some additional tweaking, you can run a 70 billion model on a GPU statically. You still need to have dynamic resources for actually processing the prompt, generating a response, right? So typically, you need to have 2 of those. Okay, how do you do that? How do you expose that? You can connect those 2 through PCIe, no link, meaning that every communication between those 2 GPUs will flow through the PCIe environment. Or you could say, no, I want to have an NVLink, meaning I have a physical interconnect between those 2 devices. And now I need to expose that to an environment. Can I do this in Kubernetes? Can I do this with pass-through? Yeah, you can. But you need to provide these 2 interconnected GPUs directly to that VM, because you cannot provide a single GPU to a VM and the other to another, because they're hardware connected, means we cannot isolate them, right? So you will have all weird configuration, right? The better way of doing these things is by using vGPU. Now the cool thing is every NVLink enabled GPU out there gets a free NVIDIA AI enterprise license, right? So you already have that functionality. Let's use it. Now, what we do is we say, hey, we know that from a topology perspective, these two GPUs are interconnected with each other. We see that there's a link that basically is done by the driver and is done by the libraries. So what we do is we expose what's called a device group to the administrator, saying, if you want to use two interconnected devices of this type, please use this device group. And then we figure out in the platform which host has these interconnected devices, where can I run it, and they don't have to specify a particular GPU on a specific host, right? Because let's say you have 8 of these in a single ESXi host. How do you know which two are interconnected? We do that for you, and we expose a general device group. Basically, it's almost saying it's a desired state. I want to have 2 interconnected H100s. That's what you say. And then we'll figure out, together with assignable hardware, together with DRS, we'll figure out which host is perfect to run. It's even so, this is brilliant stuff, what makes me really excited, is that we actually figure out if you have like 8 GPUs, right? And the way 8 GPUs typically works, if we're deep diving a little bit on a host, there are 4 on one NUMA node, 4 on another NUMA node, right? So NVIDIA always states only allocate per NUMA node. So either 2 per NUMA node, 4 per NUMA node, and if you do 8, then you have the 2 NUMA nodes because that's your hardware limitation. However, we know that. So what we do is we do 2 per NUMA node. But what if we then schedule another one on the host, right? Where do you want to place it? Do you want to place it in the other 4 on the other NUMA node, or will we place it underneath the 2 already allocated? So we have 4 open. So if a larger VM comes along with 4 GPU requirement, we can basically deploy it in the 4 that's already open. If we place it in the other NUMA node, we have 4 available GPUs, but it's not compatible when we create a 4 GPU virtual machine, right? Because we cannot span across 2 NUMA nodes only if you consume the entire host, because that's not aligned with the way NVIDIA wants to run things, right? So we have that algorithm in our DRS, in our host, that makes sense to say we want to avoid fragmentation in that way. And that's what we're already doing. So that's the great way of thinking about platform mechanisms at a cluster layer. Try to do that with your bare metal. You can't, right? And so that's the stuff that I'm thinking like, yeah, bare metal is cool, but we've got device groups, right? Now that topology, and this is the cool thing, if you look at what we've already done for the last 5-6 years with device groups and with all these things, Kate, the CNCF, basically released DRA, dynamic resource allocation, which is pretty much a copy of what we're doing with device groups. So it shows that we're thinking in the right direction. Now we need to figure out how to map that, but that's for another episode. But these are the things that we can say, look, when you start with your life cycle, you start small, you have a small model, you have a small environment, a small use case, start small. But when you're getting larger, hey, we've got all these functionality, whether it's the vGPU driver in the hypervisor, whether it's pass-through, whether it's run AI, we can help you in the most efficient way possible.
So let's say customers have the entire infrastructure and the different ways of deploying those or assigning those resources to a workload. Can you share some examples of the type of workloads that typically can run? So what are some of the use cases that you see at customers that really benefit from the platform?
Yeah. Well, it's not only the platform, it's just in general benefiting from the functionality that's being available to us today, right? Gen.AI has really revolutionized the way we interact with computers, the way we expect things to work today in a really, really short period of time, right? And so one of the key things, and you already mentioned it in the beginning about RAG, retrieval augmented generation, and I briefly mentioned it. We didn't go into detail, but in general, RAG for the customer, for the listeners who don't know this, is basically providing your own data set in a different way to a completion model. And every time when you ask a question, you basically figure out, do I have this data in my database? I'll basically give the question and the answers to the completion model, try to come up with a nice polished completion. And that's basically how RAG works. The cool thing about RAG is that you can asynchronously update your data, your knowledge base. Every time when you upload new data into your database, the completion model already has access to it. So it's not the same as fine tuning, right? When you have fine tuning, you need to go through a lengthy process to basically get the knowledge into the model. Then you need to replace the model, which is a challenge by itself. And then, of course, you never know, was it better than before? Because it's not like language is very, very difficult to understand whether it's better or not, right? It's not calculus. It's not you get a right answer, you get a wrong answer. That's not the same way with language. So fine tuning a language model, it's an art by itself. It's not taken lightly for sure. And so RAG is, for me, the easy path to getting a solution. And that's what we see with customers around the world. They say one main thing is, I have private IP that I want to interact with natural language. That's pretty much every use case out there. And so what does that mean? I need to be able to expose my private data to a completion model that I run internally, so I know no data is exiting outside our company walls. And we need to figure out who can actually access that data in a way that we see fit. There are many different use cases, and one of the use cases that I think is very brilliant, that shows the time save of all of these things, is with a legal company. So when they start with a particular case, they go into the discovery phase, meaning they need to get all the information they get, and this is typically piles and piles of documents, right? Especially when we're talking corporate law. And then they need to read through everything. That's a lengthy process, and these people are not cheap, right? So it costs you a lot of money to get through that phase as a customer. So what we've seen with certain law firms, they basically OCR scan all the documents, or sometimes they actually get those digitally supplied, and they basically put that in the vector database, the database that you tie to the completion model, and then the lawyer or whatever you want to call them, they can interact, they can ask questions to that data set. And the cool part is, because you scan your data, you already have a source. You know exactly, hey, this part comes from this document. Okay, now I can basically get back to that document because I know there's a relevant statement there, and I can read it for myself, right? So it helps to guide these people through a very lengthy process. That's one of the use cases that we see is like a time save. Now another one, which is interesting, was a bank. They said, I'm not going to expose my AI to a customer, because typically customers don't want to talk to a computer, they want to talk to a human being, but I want to make sure that my human being, my call center agent, has the complete attention to my customer. Now, if you haven't been to a call center internally, you will see that these people will have 6 screens, 9 screens, and they need to navigate through all these screens with different applications. They don't have 9 applications, they have like 50 applications running on those 9 screens, and they have to figure out, where do I get the information my customer is asking? And so typically customer calls up, says, I want to know more about X. So they have to figure out, okay, that application provides me with that knowledge about X. In the meantime, they need to engage with the customer. They need to be the human being that they want to hear, and they need to struggle, and they need to basically go through the systems in order to get to the information desired. Now with RAG, they basically said every new functionality that we provide, we put it in the database, and it's immediately accessible for the call center agent. So customer calls, ask a question about a new service, and they just type the question while they're engaging with the customer. The system searches, and the system provides an answer. I think that is the power. It's not replacing a human being, it's making the human being more efficient, right? And if we get that process in focus, that it's not about replacing but enhancing, I think that's where you see most of the Gen.AI functionality being successful.
Awesome, Frank. Thanks so much for sharing these use cases. I think they really, really make sense. And it's also kind of the typical things that we see fit as private AI use cases, because you don't want to put your data into a cloud AI service. You want to be in control of your IP. You want to secure it. So, yeah, it totally makes sense. Now we're kind of reaching almost the end of the recording, and I do want to dive into the experiment number 3, because first of all, I kind of want to recap on what we kind of learned in this episode. And to me personally, I think one of the things really stands out, and I know that for a fact because I've been working on the technology for a while as well, is that you've been doing AI for many, many years. So it's not that since the AI bubble started to kind of grow, or the kind of the AI hype started to grow, that suddenly the VMware platform became an AI platform as well. I mean, I did my first ML engagement back in 2017.
Yeah,
and back then it was, from a VMware side of things, already very easy to set stuff up.
Yeah.
Like you mentioned as well, it was a mess to build stuff within the virtual machine because there wasn't a deployment standard
machine,
yet.
right?
Yeah.
Yeah.
So that's definitely one of my key takeaways. Like, you've been doing this for many years, which is a result of a lot of R&D time, a lot of conversation with customers, and a lot of developments in the world that you are kind of ahead of the curve.
Yeah.
So to you, what's one of the key takeaways?
The key takeaway for me of all of this AI is that nobody's an expert. Everybody's trying to figure out things as we go along. That doesn't mean we don't know what we're doing, but it's all, a lot of things are, hey, how can we make this successful? And there's a lot of experimentation involved. Hey, that's the key element of science, right? Experimenting things, and the difference between real science and just let's keep this nice. Testing is writing things down, as Adam Savage would say.
Yeah.
But I think that's key. And so what you need to do is you need to get something that allows you to experiment in such an easy way that's repeatable, but also performant. And I think that's the stuff, that's the focus we have. Getting it at enterprise level, where you can still do all your experiments, where you can still do many different things with a standardized platform, and make sure that it constantly does the same thing, right? And I think without being without spending too much time on setting things up, on getting things certified, on making sure that it behaves the way it behaves, but now it's different hardware, right? All of these things, that's one of my key takeaways. The other key takeaway, and I think that's key for most of the things with successful customers, they started small. Don't boil the ocean. Start with a use case that can prove the worth of your investment. I think that's key.
Awesome. Well, and definitely the last one to me personally is that I think that VMware really with such a mature platform, it really is a Swiss Army knife when it comes to running any type of AI workload. Like because he has so many options and so many ways of doing it right. There's always one that perfectly ties into whatever your need is. So yeah, definitely Swiss Army knife.
That's a good way. We need to get a T-shirt, something
Oh,
like that.
definitely.
Yeah.
Now, I will definitely invite you over
Nice.
for a future episode, and let's say that's in 12 to 24 months from now. So,
Okay.
what is your boldest prediction for the future of private and hybrid AI? So, what's to you kind of the next game changer that we should be prepared for, and definitely that we're going to talk about in the next episode? You'll be a guest.
Okay. I need to figure out how to say this without pissing people off. So first of all, a lot of people they figure out how to do RAG. That's one. The second thing what we're going to see now is MCP, Model Context Protocol agents, pretty much, right? So how can I expose an additional data source to my RAG environment to basically make the completion richer? Now, what I believe is, by definition, MCP is a great step forward. However, what I'm afraid of is that we're going to see a lot of MCP servers that are poorly designed, meaning we're getting a lot of agents out there that we need to orchestrate, that we need to do lifecycle management, that we need to make sure that it's actually accessing the information that is exposed to the person requesting it, right? Because that's one of the most dangerous things out there, is that we're going to basically provide an MCP agent with all the rights possible, and now Tina from the front desk can basically get into the highly confidential data before the quarterly returns are exposed. Not saying Tina is a bad person. Typically, from a legal perspective, you don't want to do that, right? So that's key. The other thing is that the MCP server is just a collection of tools exposed by the actual platform itself or by the service itself. If you're just basically copying tools over and making a shorter list there, you're missing the point, because there is lifecycle management done on the service, on the platform, and every time it does that, you need to update your agent as well. It's going to be a difficult thing if you have 80 different agents running, doing just a subset of things. Figure out a way to communicate with that platform itself, right? Do things differently. So my take on that is MCP will be a force in the next 2 years. Whether everybody will be happy with the outcome, that's the question that I want to talk about in the next in 24 months. Yeah.
Awesome. Sounds like a very, very interesting episode.
Cool.
Also, the next episode, so the one after this, will be focusing on MCP together with
Nice.
my colleague Maxime Colomes, who has been spending many months on building actual MCP service for customers, custom ones. So definitely a great topic. Frank, man, thanks so much for being a guest on the Private AI Lab. Any final words you want to share?
First of all, it's my honor to be a guest of your podcast. Any wise words? No, just start playing around with it, figuring things out. Don't be afraid to not knowing things, because like I said in the beginning, most people are not an expert, right? So don't feel weird if you don't know stuff, because we've all been there, right? We're just one step ahead of your journey, right? Of 2 steps ahead, but nobody completed this journey yet. So
Yeah,
engage with community, right? There are many different communities out there. One of the greatest one out there is the MLOps community. It's a tremendous
definitely.
community. They have great Slack channels. They have a great podcast. They have great videos. Demetrius is doing a great thing. I would certainly, next to your podcast, of course, check that one out.
Awesome. I will leave a link to that in the show notes. Also to your blog, frankdenneman.nl. If people want to reach out to you, is that the best way to do it, or any other
LinkedIn.
channels?
I haven't been updating that one for a long time because my role changed, right? So it's I don't have, unfortunately, don't have much time anymore to spend blogging. Yeah.
Awesome. Well, thanks again, and we'll talk soon. Thanks for tuning into the Private AI Lab. Don't forget to subscribe to Spotify, Apple Podcasts, or YouTube, and visit johan.ml for more insights and experiments. Experiment complete. Until the next one, stay curious.